In this video, we're going to continue to talk about slope-intercept form, but today we're going to focus on writing the equations of the line in slope-intercept form. So we know slope-intercept form is y equals mx plus b. Remember, the slope is the m, the y-intercept is represented by that b value, and then x and y are any point on that line. And that's going to be really important today. So we want to write the equation of the different representations below in slope-intercept form. So we want to start by finding the slope and the y-intercept to write that equation in slope-intercept form. So it's pretty easy on a graph to pick out the y-intercept. Here we see our y-intercept is where the graph crosses the y-axis. Our y-intercept here is at 0, 10. So that tells us our b value is going to be 10. Now we have to find the slope. And remember, the slope comes from all of the points that are on the line, right? That's the x and the y values. So we're going to, again, find the points where the line crosses right at the corner. So there's a couple of these that are highlighted. Sometimes the points will be there for you. Sometimes you got to pick them out yourselves. And again, it doesn't matter which points you choose. Your slope is always going to be the same. And remember, slope, remember that's our m. That's going to be rise over run. So starting from this y-intercept, I'm going to count my rise, and I am going actually down 2, and I am going to go to the right 1. So the slope of this line is -2 over 1, or we can just write it as -2. That's fully simplified. So plugging that into our equation, the y is always going to be in our equation. The x is always going to be in the equation. We need to plug in the m, which is our slope, -2. And we need to plug in the b value, which is 10. So the equation of this line is y is equal to -2x plus 10. Next, we're going to write an equation of a line that passes through these different points represented on this table of values. So same thing, we want to write the equation in slope-intercept form. So we're going to find the slope and we're going to find the y-intercept. So the y-intercept, again, just like above, we know our y-intercept is always going to be 0, something, right? That's going to be our b value. It's going to tell us what our b value is. And I see 2 zeros on my graph, or on my table, but this very first point, 0, 2, that is my y-intercept. If you were to graph that, you would find that that point would cross the y-axis at 2 right there. So our b value is going to be 2 from this equation. And now we're going to find the slope. And you can either do that with the slope formula that we learned earlier, or you can use just looking at the tables, again, finding the change in y and the change in x. So just looking at the table to get from one y value to the next, every single time I'm going to be subtracting 2. That's my change in y. So my slope, my change in y over the change in x. We just said my change in y is -2. Here, my change in x, I'm actually going up 5 every single time. So my change in x is 5. So my slope is -2/5. So again, in the equation, we're always going to have y and x. I'm going to plug in -2/5 for m, my coefficient of x, and I'm going to add 2 at the end for my y-intercept. So my final equation for this table is y is equal to -2/5 x plus 2. Last, we're going to find the equation of a line that passes between these 2 points right here. So again, we have to find the slope and we have to find the y-intercept. So you can find the slope using whichever method you like. I'm going to use the equation where I take my 2 values, my y values, and I subtract y2 minus y1 and divide it by x2 minus x1. When I simplify, minus a negative in the numerator there, we get -4. In the denominator, we get 12. we know we can simplify that. I know that my slope 4 goes into both the numerator and the denominator. So my slope ends up being negative 1/3. It doesn't matter if that negative's in the numerator or the denominator or out front. A negative 1/3 is our answer. So now we have the slope, but we need to find the y-intercept. So in the equation, we know we have y is equal to negative 1/3 x, but we don't know b. We're not sure what the y-intercept is, and neither of these 2 points are the y-intercept, right? If this point was 0, negative 5, our work would be done. Our y-intercept would be negative 5. But since our y-intercept is not given, we have to find it. And this is where that idea of the y and the x in the equation represents a point on the line. So we need to use that idea because we have 2 points right here that are on the line. So it doesn't matter which one you pick. Pick either point, whichever numbers look nicer to you or which ones you would prefer to be working with in this equation. And we are going to plug them into the equation for y and for x. I'm going to go ahead and just use this first point. I'm going to say 1 is x and negative 5 is y. So I replace x and y with 1 and negative 5 in my equation, like I have here. And now I can solve this equation for b. So I'm going to follow order of operations. I know negative 1/3 times 1 is just negative 1/3. And now to get b by itself, I'm going to add 1/3 to both sides. And remember, when we add fractions, they have to have common denominators. So I could rewrite negative 5 with a denominator of 3 as negative 15/3. So if I replace that negative 5 with negative 15/3, negative 15 divided by 3 is negative 5. So now I can add negative 15/3 plus 1/3. That's going to get me negative 14/3 as the b value. And you can change that to a decimal if you want, but I'm just going to leave it as a fraction. So that's going to be my y-intercept. My y-intercept is a funky number, negative 14/3, which means my b value, which we just found, is negative 14/3. So now I can rewrite the equation, leaving my x and my y now as a variable. My slope is negative 1/3. My intercept is negative 14/3. So my equation of the line is y equals negative 1/3 x minus 14/3.